and it is my privilege and honor to introduce our distinguished lecture speaker today, Dr. Ajay Mathur, who is going to talk about energy efficiency in India, challenges and initiatives. Dr. Mathur is Director General of the Bureau of Energy Efficiency in India, and he's also a member of the Prime Minister Council of Climate Change. In his role, Dr. Mathur is responsible for coordinating energy efficiency programs in India that range from standards for appliances and energy conservation building codes, as well as industrial energy efficiency program in the entire country. Dr. Mathur received a bachelor's degree from the University of Roorkee in India, and then he traveled to the United States, where he received master's and PhD degrees from the University of Illinois in Chicago. Then he joined the Tata Energy Resources Institute, when he spent almost 15 years. Yes. And then he worked for the World Bank, in which he coordinated efforts in integrating climate change into policies in developing countries. Under his role and management, almost $2 billion were granted in form of credits for different climate change energy-related projects. Dr. Mathur joined the Bureau of Energy Efficiency in India in 1996, in which he stayed for the last 4 years. So today's talk, he's going to present us some of the activities that he's managing and responsible for. Dr. Mathur, the floor is yours.
Thank you very much, Robert. Thank you, Robert. Ladies and gentlemen, it's a great honor to be here today. When I was asked, when Jayant asked if I would be willing to do this, I jumped at the opportunity. And part of it, of course, is that LBNL has a tradition of excellence, is known as a place where very smart people live and work. And therefore, I thought that if anybody can provide us with first-rate experiences, analyses, comments on what we do, it would be here. And I must say that I'm looking forward more to the discussion that follows this presentation. In the presentation today, what I'd like to do is to share with you where we are as far as energy efficiency or the energy use is concerned, the dynamics of energy use in the country, not so much the supply. And then walk you through the kinds of initiatives that have been put into place to address the issues of energy inefficiency. And at the end, share with you some of our thinking on new initiatives as well. Well, to begin with, let's see where we are as far as energy use is concerned. And it's marked by a huge deficit in the use of energy. It is marked by a very limited access. Only 50% of the people have access to electricity or clean cooking fuels. It is also marked by a general shortage of energy resources. Petroleum, of course, is imported. 70% of petroleum and petroleum products are important. But more importantly, over the last few years, even coal, which we had always seen as being the mainstay of the Indian energy economy, is now being imported. Therefore, both on a supply side as well as on a demand side, we are on a hard wicket. Because of this, I believe, and we'll share a few other reasons as we go ahead, the energy intensity of the country has been declining. It's always difficult to compare energy intensities across economies for a variety of reasons. What we show here is the energy intensity based on the gross domestic product measured on a purchasing power parity basis. And the relationship to the availability of energy and the need for energy is clearly seen in these graphs of the way in which energy intensity has been occurring in these various countries. If we look at India alone over a period of time, we see that there has been something of the order of about a 25% reduction in the energy intensity over the first 7-8 years of this decade. Why has that happened? We believe that there are three reasons. The first is that in the 1990s, as the economy liberalized and was opened to global competition, it became very important for companies, particularly industry, to focus on bottom lines. And energy costs is one of the major areas in managing bottom lines. And consequently, what we have seen is that as new industry has come up, each one is more efficient than the last, and many of them are amongst the most efficient in the world. The second reason is that there has been a shift in the structure of the economy so that we have a larger services sector. This has implied that there is a lot more buildings needed, because at the end of the day, what does services need? Buildings. And we will talk about it a little more as we go along. But the greater mix, the greater percentage of services in the mix has also meant that the energy intensity has gone down. And the third reason is prices. If you look at Indian industry, they face amongst the highest prices in the world, whether it is for electricity, whether it's for fuel oil, whether it is for gas, and even for coal on a kilocalorie basis. And as far as the rest of the economy is concerned, they face amongst the highest prices in the world for electricity and for gasoline compared to their incomes. Because as far as you and I are concerned, our expenditure, whether it is on housing, whether it is on energy, whether it is on clothing, largely depends on how much money do you have in your pocket. This may or may not be the best measure, but it gives you a feeling of the affordability issue. And therefore, I think this is one of the reasons why India has generally tended to be frugal in its use of energy. However, as we look ahead, we see energy demand increasing dramatically. And this is for the reasons that I mentioned earlier. A very large number of people don't have access to electricity or cooking fuels. And if they want to have a decent quality of life, energy use is an essential part of it. If we want people to have decent incomes, and therefore investments in industry or the services sector, that also requires energy. And all of that energy requirement implies that there is no way that the demand for energy would not increase at least by a factor of 2, but maybe by a factor of 3 over the next 20 years. Now, juxtapose this with the issue that the energy resources are limited. And we are in a very tight situation. But we tend to look upon it as an opportunity. If this much energy is going to be used in the future, that means that the vast amount of infrastructure is yet to be built. And therefore, if we can influence the design of that infrastructure, it gives us an opportunity to also influence the amount of energy demand in the years to come. As an example, it is expected that 70% of the commercial buildings that will be there in 2030, fully 70% of them would have been built between now and then. This, therefore, means that we need to ensure that each commercial building that is built now is more efficient than the last, much more efficient than what has been done in the past. This, of course, is very different from the situation in other countries. For example, in this country, where because the turnover is relatively slower, the emphasis has been on the retrofit and upgradation of current stock, whether it is in buildings or in industry. Now, while this is an opportunity, it also presents challenges. And it presents challenges because of a few key reasons, which are no different from what they are in other parts of the world. High first costs. An energy efficient bulb costs more than a normal incandescent bulb. Yes, it does. An energy efficient air conditioner costs more than a less efficient air conditioner. And therefore, particularly for households where discount rates are high, it becomes an issue, it becomes a challenge how to convince them to invest in a more expensive product. With industry, it's slightly different. And that's the issue of the fact that new technologies, including new energy efficiency technologies, are perceived as being risky. Why? I mean, all of us have had this kind of an experience. Somebody walks through the door and says, here's this gizmo. Plug it into your wires and your energy bill will reduce to half. Sure. Everything may come tumbling down as well. Here I am running an industry, making a profit, and you come and tell me, here is this widget, put it in, and my energy bill becomes half. I would just stop production and all my profits are gone. And that's the reason why industry tends always to look over its shoulder and ask, who else has done it? Therefore, with new technologies, this is a kind of a chicken and egg situation. And therefore, again, it's an area where public policy is needed to break this kind of chicken-egg problem. The third issue, which is much more a buildings issue, and again something which is seen around the world, is the issue of a split incentives. The fact that the costs and benefits accrue to different people. If I am a developer and I make an energy efficient building, it costs a wee bit more. And then I come and I want to sell it to you. And I say it costs 10% more. And you ask me, why on earth should I pay 10% more to you? He has built another building which is just like yours, as fancy, and I'll buy that. And the developer grumbles, but finally accepts something which is closer to the price of a non-energy efficient building. Of course, when you end up buying the building or you end up renting it, the tenant, whoever is in the building, gets an energy bill which is lower. So this problem of costs and benefits being different in terms of people and being different in terms of time need to be breached. How do we get over these kinds of barriers? What is clear is that for a country where development is occurring at a fast pace, the choice of technology is a key issue. We believe that it is particularly an important issue in these sectors. It is obviously important in other sectors as well, but this is where something like 80% of the energy consumption of the future is going to occur. And therefore, if I can influence buildings, if I can influence the technologies for power generation, if we can influence the efficiency of equipment and appliances, of waste heat recovery in industry and so on, we would have made a difference. It was with that in mind that the Energy Conservation Act of 2001 was passed by the Indian Parliament. And it does a number of things. Because when you go to buy an energy efficiency, an equipment or an appliance, and you don't know how much energy it uses, labels help. I mean, this country pioneered labels about, 25, 30 years ago, and therefore it gives the legal mandate to issue similar labels in India. Energy consumption norms for industry, again the point being that industry, in a sense, is already incentivized because of the issue of managing its costs to invest in energy efficiency. Yet, in an economy where growth is very fast and the amount of money that an entrepreneur has is limited, he could put it in energy efficiency. He could also put it into expanding his production. He could also put it into making some entirely new product. And obviously what we want to do is to get him to invest in energy efficiency. And therefore, the reporting requirements were put into place so that energy efficiency, which in industry had tended largely to be a boiler room issue, becomes a boardroom issue. It's now the board which looks at how energy is used and makes that report, very much like an income tax return being filed every year. There's the Energy Conservation Building Code, which needs to be done for commercial buildings. And this is something that Parliament debated on and said that at least for this moment of time, they want to keep homes out of it and focus on commercial buildings, because that's where the vast bulk of energy is used and where the bulk of potential for savings exist. In order to make these things happen, they also provided a mandate to certify energy managers and energy auditors who would be the front end of this. And one of our leading energy managers, Mr. Jeraman, is here with us today. More recently, the Prime Minister launched a climate change action plan within which there is a national mission for enhanced energy efficiency, and that also provides a new kind of a mandate. This is for industry. And apart from the reporting mechanisms, what it does is it seeks to create a market incentive for industry to do more than what it would do under normal circumstances. So let's walk through these 3 or 4 things. The labeling program is very similar. It was developed in consultation with and with the advice of US experts, including those from the lab, and therefore, in a sense, also looks in a manner similar to the labels that you have in this country. This is what is there for, say, a refrigerator. Tells you how much kilowatt hours it will use in a year, how does it compare with all others in the market. But what we've also done is introduced a similar label for buildings, under the assumption that when you and I go out looking for office space, we do want to know what would be the kind of energy consumption that would be there. And therefore, we drive a demand for energy efficient buildings. And what it does is it reports the energy performance index of a building in terms of kilowatt hours per square meter per year based on actual data. We look at what the bills were for the last year, and therefore what is the amount of energy they used, what is the built up area, divide one by the other to get this energy performance index. The approach that we have taken is that at the end of the day, we need to support consumers in making decisions which are in their own interests. And therefore, we introduced the labeling program as a voluntary program. Initially for refrigerators, air conditioners, fluorescent tube lights, distribution transformers. And then advertised heavily. So that you and I as consumers came to know about this, came to know the benefits of the label, and then went into the market and voted with our pocketbooks. Within a matter of 2 years, 75% of the refrigerators and 50% of the air conditioners that were being sold in the market were labeled products. What it did was to give an ambiguous signal to manufacturers that people are willing to pay more for energy efficient products. I believe that this was a very strong signal. And consequently, every manufacturer started producing a line of labeled products. When we saw this market transformation occurring, that's when we made it mandatory. The point I want to stress is that we did not make it mandatory to begin with. Because what we were afraid of was that if consumers are unwilling to pay the additional money that is needed for the energy efficient appliances, we would be stuck with a program which had no takers. And so this is a approach that we are now using for a range of appliances. There are many other products which are currently on the voluntary labeling stage. As the transformation occurs, they would also be made mandatory, and the process would keep on continuing. Let's look at industry. As I mentioned earlier, industry is an area where we have seen a large amount of energy efficiency occurring. But one of the things that we observed was that there is a huge bandwidth in the energy efficiency of units within the same sector. Let me see, I hope I have, here it is. Here is the cement sector. This guy is the most energy efficient cement maker anywhere in the world. But this guy uses twice as much energy to produce a ton of clinker as compared to the more energy efficient person. If you look at paper, that's an order of 3. This is somewhat unusual. In most countries we find that the bandwidth is far narrower than what we see in India. And we believe that this is because growth is occurring very fast, and therefore both new plant as well as old plant are able to compete. The new plant competes on the basis of its efficiency. The older plant competes on the basis of the fact that it is fully depreciated. This, of course, presents a problem to us. It presents a problem on how on earth do we address this issue of reducing this bandwidth. Now, under the Act, the Energy Conservation Act, we were empowered that we could designate the most energy intensive units as what are called as designated consumers. And designated consumers are supposed to get some things done. But one of the things, as you will note, that they're supposed to do is to comply with energy norms. Now, how on earth do we set these energy norms when there is such a large bandwidth? If we set it here, these guys would almost definitely have to close down. There's no way that the engineering configurations that they have could be changed so that they move from here to here. On the other hand, if we set it here, that's meaningless. So what we have done is that we are requiring everybody to increase their specific energy consumption by a certain percentage. So this fellow has to reduce his specific energy consumption. It's 500. He has to reduce it by some number, let's say 3% over a 3-year period. This person also has to reduce, but he has to reduce by a larger amount, say 7%. So everybody who's a designated consumer has to reduce their specific energy consumption, and the percentage reduction is smaller for the more efficient units and larger for the less efficient units. Now, this creates a competition within the sector, because once they are put into these various blocks, and we call them gold, silver, bronze, and tin, there is also a competition to move from one of these categories to the other. This is how things are today. But with the Prime Minister's National Mission on Enhanced Energy Efficiency, we have gone ahead and added something on top of it. And that is, these goals are already there. They have to reduce their specific energy consumption, and there's a percentage reduction by which they have to do it. But if they do it more than what their target is, and the target is really set on the basis of how efficient they are compared to the rest in that sector. If they are able to do better than their percentage reduction target, then we will give them an energy saving certificate for the excess savings. So here's a steel plant which is today using 7 gigacalories of energy to produce a ton of steel. And say his target is 5% reduction. So he has to go down from 7 to 6.65. This is what his target is. But he does better. He goes down to 6.5. So for the difference between these, 6.5 and 6.65, we would give him energy saving certificate. What will he do with them? There are other guys who would find it very expensive to meet their own reduction targets. And therefore, they can buy these energy saving certificates for compliance purposes. So as far as we are concerned, we get the savings we want, the total savings. But the country gets it in the most cost-effective manner. This is something that we are now in the process of doing. There's a mistake here. This should be 1st April 2011. Obviously, this requires an amendment to the Energy Conservation Act. The amendment bill is in Parliament. It has been passed by the lower house, and hopefully when Parliament meets again in a couple of months, the upper house will pass it as well. And consequently, what we hope that this would do is incentivize people, incentivize industry to do more than they would have otherwise, because of the possibility of this other stream of income that could accrue to them. This is large industry. What about small industry? Small industry is a completely different kettle of fish. Why? The major problem with small industry is that it is run by an entrepreneur who has almost no engineering capability. He often is the only engineer there. And therefore, who is going to tell him what can be done, what are the kinds of opportunities, where does he procure it from, what are the metrics that are used? And therefore, as far as small industry is concerned, what we are doing is going into these clusters of small industrial units. And it's very interesting that these clusters are geographically located. So in a particular city, for example, the city of Khurja, which is not very far from Delhi, there is a cluster of ceramic industries. All of them very similar to each other in a technological manner. Also competing against each other, learning from each other, stealing people from each other. In other words, within that cluster, the dynamic of learning from each other is amazingly impressive. So what we're doing is, within this cluster, we are taking in experts who identify what are the kinds of opportunities and work with local service providers, local consultants, who develop these reports for 1, 2, 3, 4 people, so that they cover the kinds of technological configurations that occur. We also have an arrangement with the Small Industries Development Bank, who comes and makes these reports such that they address all the questions which a bank would ask if you go to them for a loan. We bring in the people who would be the solution providers, the equipment vendors and so on. Introduce them to the industry and introduce them to what needs to be done. As the first projects get done, because of the dynamic of learning that occurs in the cluster, other people then want it. The local service providers, the local consultants are there to provide this service. They look at it as a business opportunity. The equipment vendors, the solution providers are there looking for more opportunities for business. They push it. And of course, the banks are comfortable in lending for this because they've been involved in its development. So what it does, hopefully, And we are still not at the very end of it where we can see this large-scale replication occurring. So what we see, hopefully, is a sustainable market being created within the cluster for energy-efficient goods and services. Let me move to buildings. This is an area in which we have had a formal relationship with this lab. One of your professionals, Satish Kumar, on leave, heads the USAID Contractors Office, which is supporting us in the implementation of the Energy Conservation Building Code. By far and large, what the code does is, like any other code, tells what is the kind of window that you can have, what is the kind of insulation you must have, what is the kind of heat rate across the walls, the efficiency of the chillers and all that. But again, the problem that occurs is, how do we make this happen? So on the one side, we are pushing with the code, training architects, bringing this into government construction. But on the other hand, through that label that I showed you, also creating a demand pull, apart from the push, the supply push that is being done by the code itself. Does it work? Well, let me give you an example. The Indian Institute of Technology in Kanpur has made something called the Center for Environmental Sciences and Engineering. When it was initially designed, it would have used about 240 kilowatt hours per square meter per year. But as they went through the application of the code for the walls, for the lighting system, for the HVAC system, yes, the cost did increase. It went up somewhat. But the energy bills would come down, and therefore, over a period of time, these additional investments pay back for themselves. So what we found was that starting with 240, it has come down to 98. A substantial reduction of 40% of what it was earlier. And this we are finding in building after building after building. When this building was initially constructed, the additional cost was something of the order of about 15 to 20%. In buildings that are being constructed now, the additional cost, the differential, is something of the order of 5 to 7%. Insulation is available in larger numbers, chillers are available and manufactured in India, so all the economies of scale kinds of issues are coming up, making this whole experiment, this whole market more cost effective than it was to begin with. What about existing buildings? While we completely understand that in the future it's the new buildings which would be the vast majority of buildings that exist, existing buildings won't disappear. And therefore it's important to address them as well. And therefore the goal has been to create performance contracting markets based on energy service companies. And again, it's a learning that we have borrowed heavily from this country. We are on the one side bringing in a lot of buildings into the market, particularly government buildings. Again, learning from the FEMP experience. And on the other side, also asking companies to come in and work as energy service companies. Recognizing that at the end of the day, this is a market function, we get these companies to be rated by the market rating agencies, the Standard & Poor and Moody's kind of people do a rating of the energy service companies so that the user and the banks are also comfortable in working with them. We are doing it for buildings. We are also using the same model for municipal lighting and water pumping, for agricultural pump sets, for demand side management with utilities and so on. And as a signal, as an important token, the first building that went through this was the President's House. And there, the savings that we are seeing over 2 years is something of the order of 20 to 23%. And that, I believe, is our strongest marketing card, particularly in the government. Let me also share with you something that we are rather proud of. And this is an effort to move away from incandescent bulbs to CFLs. And what we, again, first cost is what the challenge is. And if first cost is the challenge, how do we get over it? In the commercial sector, we have seen that CFL penetration is almost complete, 90-some%. But in households, it's something like 8%. So what we're doing is establishing a program within which companies come in, and in a geographical area, project area, they come in and sell CFLs at the price of an incandescent bulb. How do they recover the rest of the cost? That's through carbon credits. Because CFLs use less electricity, because therefore there's less carbon dioxide emissions, therefore they earn carbon credits, and those carbon credits accrue to the company, which then sells them globally and recovers the costs plus profits. If each of these had to be registered as a carbon credit project, a CDM project as it is called in the UNFCCC, the Framework Convention on Climate Change lingo, that would take a huge amount of time. It's a difficult process. And therefore what we have done is registered a pan-India, what is known as a program of activities, within which individual small projects which fit in, as long as they are completely alike, they fit into this larger project, and that greatly reduces the transaction costs and transaction time. This POA was registered a few weeks ago, is the largest CDM project in the world, and we are looking to replacing 300 to 400 million incandescent bulbs through this process over the next 2 years. Let me start by concluding the various programs that we have put together. One of the things that we have sought in all our programs is to address both the demand side as well as the supply side. So we are creating at the same time a demand for energy efficient products and services, and at the same time also pushing that these choices are available in the market. And this is across all sectors of the economy, and we have talked about most of them. Do these actually result in savings? Well, the program is now about 3 years old. And what we have seen is that the total fossil fuel consumption in India is about 400 million tons. In the last year, the savings that is only because of these programs is something of the order of 10 million tons. This is not yet verified. It may go up or down depending on the third-party verification results. And the avoided generation capacity over the last 3 years is something of the order of 5,000 megawatts, which is a big deal when you look at the way in which new power capacity is being added in India. We are therefore looking in our design of policies as those which in a sense provide nudges to you and I in making decisions. Energy efficiency makes sense to each one of us. We are not able to do that because sometimes the choice is not available, because sometimes even if the choice is available, information is not there. If information is there, the financial wherewithal is not there. And therefore the policy nudges are really about putting these kind of an environment within which each one of us is empowered to make the energy efficient choice. One of the things that we have learned is that as we create these markets, the first few transactions are important. And a huge amount of hand-holding is needed. How should the terms of reference be written? How should the contract be written? How will the baselines be done? How will the monitoring be done? And actually do it. Stay with the two people who are the parts of the contract, the supplier and the customer, and make this happen. It's only then that the larger scale replication occurs. This is something we have learned the hard way, and therefore we find that typically in any new market, 1, 2, 3, 4 transactions occur, and then suddenly it takes off. I'd like to spend a couple of minutes looking at the future. At Copenhagen, President Obama put forward a program called Climate Ready, and it had a renewable energy component and an energy efficiency component. And the energy efficiency component really was about providing incentives to manufacturers who bring very efficient, super efficient products into the market. This is an idea to which Jayant and his colleagues have helped develop, and it's an idea that we thought would make great sense. So what we are now in the process of doing is putting up such a project in India, again with the help of Jayant and his colleagues, and the goal is that we set up standards for a super efficient appliance, something which is, say, 50% more efficient than what is available today. And then work out what is the benefit to the utility. And that is, some part of it is paid as an incentive to the manufacturer for every super efficient appliance that is sold in the market. Easier said than done. There are a lot of corners that need to be rounded, a lot of threads which need to be put together, but this is something that we have now moved to the regulators, and the regulators have agreed to go ahead. The second area, which I think is much more important to us and would probably be of greater interest to an audience at the lab, is how do we look at research? Everything that we have done till now is really about moving current technologies into the market. But there will come a point, 2 years, 3 years later, when we will have to look at new technologies, new products. Where will they come from? And so what we decided was that let us look at a few things which would greatly influence energy use in the future. And we thought that the 3 things which are of importance to us are LED-based lighting, air conditioning, and waste heat recovery. Okay, how do we get products around this? And we therefore decided that the first thing that we would do is play a facilitation role, bringing together potential developers of this and potential buyers. Why? What is the performance that people expect out of it? The buyers expect out of it. What are they willing to pay for it? So this conversation leads to a broad set of performance and cost targets for the technology suppliers. It's happened in the waste heat area, it's happened in the LED area. We hope that in the next couple of weeks it will also happen in the air conditioning area. Next, we support the technology developers through technical assistance. Now this fellow says, for waste heat recovery, what I need is Mr. X at LBNL or wherever who is an expert on organic Rankine cycles. Well, we would pay to get that technical assistance. Or he says, I need a product designer. Or he says, I need a supply chain management person. So provide the technical assistance that is needed. Second, as the product is developed, get the first few working. This is an area which is traditionally called the valley of death, because neither is the government willing to pay through research funds, nor is the consumer willing to pay for the full cost of the product. And therefore provide partial assistance so that the first 2, 3, 4 projects are carried out. We learn from each one, what is known as the probe and learn approach, learn from it, make changes, do the next one, and so on. Again, this is something which is under development, and again we hope that before the year is out we would have this off the ground. I'd like, however, after all of this, to leave you with a thought. What all of this does is ensure that energy efficient products and services are available to consumers. So the air conditioner that you would have or the car that you would have would be more efficient than the one you had yesterday. And hopefully you buy the most efficient that is available in the market. However, it doesn't help if you choose the wrong product. A colleague of mine, a German who spent many years with us, used to show this picture of a half-filled glass and ask whether it is half full or half empty. And said that, if you've asked that question, you've asked the wrong question. The problem is that the glass is too large for the work it has to do. And in a very similar manner, we can buy an air conditioner or a car which is very efficient, but if it is too large for the work that is to be done, we've only partially solved the problem of energy management. I thank you for your attention.
Well, thank you for a very interesting lecture. The floor is open for discussion. Any questions?
Jake, could you explain the waste heat recovery, what temperatures you're talking about, what kind of applications?
Sure. The temperatures that we are talking of are typically 120 degrees centigrade to 180 degrees centigrade. This is the range in which about 30% of the energy that is used in industry is actually let out at. It is also an area in which the only real product that is available today is vapor absorption air conditioning. Apart from that, there's no real product which uses heat at this, and obviously for an industry, air conditioning could be of use, but limited use. And therefore, what we are focusing on really is power generation. And that's why we are looking particularly at organic Rankine cycles, which can make this occur.
Could you comment on the basic research that is being done either at the universities or research institutions in India on the energy demand side as well as on the energy efficiency side?
Unfortunately, and this is something for which I take part of the responsibility, there is almost no research which is done on the end use side. Whether it is technological research, publicly funded research. Obviously, the Carriers and the Thermaxes of the world do the research themselves. Neither on the technology side nor on the policy side. And this is something that we need to set right, hence this last initiative that I spoke about. What we have done is, over the past year or so, together with the Department of Science and Technology, started out a program on energy-based basic research. And this is a much broader area than, again, just end-use research. End-use research, materials and so on are part of it, but also it includes things like biodiesel and so on. But what we believe is that the linkage between this basic research and the goods and services that would be needed by consumers ultimately, that linkage has not been made.
Thank you. A question about the sectoral targets that you have for industry. If you could, to what extent, what would happen to firms that fail to comply? And are they a function of the technology that's installed for the different firms, or are they industry-wide?
Okay. If they don't comply, they have to pay a penalty. At the moment, under the Act, the penalty is a relatively small financial amount. But in the amendments that we are moving through Parliament, the penalty is actually the cost of energy. So if we had to reduce by, say, 200 tons, and did it by 150, including buying of certificates, etc., the shortfall is 50. And therefore, the penalty to be paid is 50 tons into the cost of a ton of oil. Then your other question was about how are these targets set. In a nutshell, if we look at any one sector, say cement, we know the most efficient plant. And we know the efficiencies, the specific energy consumptions of the other plants compared to this. So this fellow is at 1, then there is at 1.05, 1.1, 1.2, whatever. The percentage reduction that each one of them has to do is in relation to their efficiency compared to the best. We don't care what the technology is inside. For us, the specific energy consumption is a gate-to-gate measurement. Total amount of energy coming in, total amount of products going out, one divided by the other. It's brutally simple. Yes, we lose a lot of detail, but remember, each one of them has a percentage reduction target compared to their own current specific energy consumption. They're not competing with anybody else. There is no single benchmark that all of them have to come to. I have to be 5% better than what I was last year. And that is why the gate-to-gate approach works. Yes, it could happen that he starts producing a lot of other products. Then you would have to make corrections for that. Yes, it is possible that there may be large changes in the energy mix. It is but what we would like them to do is to, inside their industrial premises, for example, put up cogeneration. Then the total amount of energy coming in reduces, and the specific energy consumption becomes better. There was also a huge discussion in the Prime Minister's Council, and we were told not, again, to add the energy that is produced from renewables in the plant. So if he is using biomass, it's not added. So in theory, what we fear is that somebody moves completely to biomass, he could have a specific energy consumption of 0. So there are a few corrections that are available for large-scale changes that occur. It is possible that the capacity utilization factor of the industry falls from 90% to 40%. So those kinds of things would be corrected, but by far and large, it's a gate-to-gate approach.
Could you say something about the budget for energy efficiency vis-a-vis the budget for renewable energy, and whether the investments or the budget reflects the cost effectiveness of investing in these two things, and how much of the budget is short-term versus the long-term?
Let me ask you a question. And that is, if energy efficiency is very effective, should the budget be larger or smaller? Now, if I'm a government official, in a sense, my place in the totem pole is based on the size of my budget. So I would like it to be large. But the main problem, for example, comparing with renewables, is that in renewables, most renewables, with a few exceptions, are not economic in themselves over a period of a time. And therefore, you need to subsidize them. That subsidy is part of the budget. In the case of energy efficiency, I don't need to subsidize anybody. I only need to nudge them into adopting the energy efficient option. Why should I subsidize them? So, therefore, because of that, the budget for energy efficiency is smaller than the budget for renewables. But the impact of energy efficiency is many, many times that of the impact of renewables. But if you compare over the past 4 years, the budget for energy efficiency has increased by 400%. But so money is not an issue. I mean, we have more money than we can actually spend.
I was wondering what the role of Department of Science and Technology, technology business incubators, and science and technology entrepreneur parks have in this tech development and commercialization of these.
Yeah. Science and technology does two things. One is, of course, fund the basic research, which I was talking about earlier. But I'm very glad you brought up the issue of incubators, because one of the things that we are seeing is that people have great ideas, but to help convert them from the mind to the market, there is a huge amount of support that is needed, which these incubators are beginning to provide. So there are 2 or 3 incubators which have kind of, over a period of time, developed into energy incubators, or even I could say energy efficiency incubators, Pune, Trichy, and so on, where people are particularly looking at innovative products which reduce energy consumption.
You mentioned in your talk that ESCOs are rated by Standard & Poor's or other organizations. I wonder if you could comment on, first of all, generally how effective ESCOs have been. And the reason I ask is that in this country that there's considerable, I think, concern that ESCOs really only capture a portion of the savings, often spoil the opportunities for deeper savings, and so the whole role of the ESCOs and how they operate has been is under some scrutiny or under debate, certainly. And I wondered what the Indian experience had been, and I wondered how the way they're rated by the financial organizations, whether that has any bearing on that issue.
ESCOs do have a contested position in India as well. For all the reasons that you said, for all the reasons that are there in the United States. In fact, that's one of the reasons why we went through with rating them. Because they were having 2 key problems. One was clients wouldn't know whether to give a job to A or B or C. And second was that banks were having a very hard time in giving out loans for energy efficiency projects done through ESCOs. What the rating agencies grade them on is 3 things. The most important and the largest percentage in the grading system is their project management capabilities. The next is their financial money raising and financial management capabilities. And the third is their technical capabilities. And they're rated on a grade of 1 to 5, 1 being the best, 5 being the least. And there are other companies which don't make it at all. And what we noticed started happening in the market, that the job would go to a grade 1 or grade 2 ESCO, and he would do a back-to-back arrangement with a grade 3 or grade 4 ESCO, who would actually do the job. And that is fine with us, because what it did was it also raised the quality of the 3 and 4. In fact, in the second round, some of the grade 3 ESCOs have become grade 2 ESCOs because of this piggybacking or contractual agreements that they did. It is very correct that ESCOs tend to cherry pick. They tend to do those energy savings investments where the largest returns occur. In fact, right up front, what we did when we were creating the market was that we had what we called as investment grade energy audits done for a very large number of government buildings, 200 or 300 of them, so that they knew what the opportunities were. And therefore, when they put the terms of reference out, they said, you have to do a minimum of so much. So kind of empowering the client, the building owner, helped. We are now seeing a very strange, maybe it's the success of the ESCOs. For example, the government agency that manages buildings, it's called the Central Public Works Department, now says, We don't want ESCOs, we'll do this ourselves. We don't see why we have to pay ESCOs to do it. And as far as we are concerned, we don't care. I mean, if you do it, all power to you.
Thank you.
Contracting in ESCOs, the cost is borne by the ESCO, not by the building owner, or at least partially. And the ESCO is paid out of the savings that occurs. So that's one of the ways in which the building owner, we get the building owner on board. But I think the more important issue that you said was, how do we get more and more buildings to be upgraded in this manner? We have, by government fiat, brought in all government buildings above a certain size. As far as private buildings are concerned, what we have seen is that private buildings which are owned by corporates, who also pay the energy bills, there we have started seeing a movement of going through retrofitting, either themselves or through energy service companies. The problem occurs when you have a building in which there are 20 people who either own space or rent space. And that's a challenge, I guess, which occurs everywhere in the world, and we're trying to find out contractual ways of overcoming it. But what has also happened is that various civil society organizations have taken it upon themselves to go out and convince building owners that they need to upgrade it. The Clinton Climate Initiative, for example, has taken a goal that they will bring 200 private sector buildings for upgradation through this process.
Thank you for your presentation. One question, you mentioned the Energy Conservation Action 2001. There are some energy consumption norm, NORM. Is there any in this kind of norm for steel industry?
Well,
thank you.
As I mentioned, our problem is the huge bandwidth. There are some steel plants which are very efficient, there are others who are very inefficient. And therefore, instead of having a single norm for the entire industry, the way we have gone is that there is a norm for each unit. Each unit has to become more efficient than what it was earlier. And the most efficient one has to become efficient by a smaller amount. The least efficient one has to become more efficient by a larger amount. But there is no one single norm for any sector.
Thank you for your great talk. You said lifestyle choices matter, and I'm interested to know, in addition to the advertorial campaigns that you have on TV and radio, how do you think that actually making consumers more aware of these opportunities is going to be, in addition to the BE, other sectors, the non-governmental sector, industries, employers, who's going to take on the role of managing demand on a bigger scale?
It's a very good question, and one to which at least I do not have an answer. What we do is we promote alliances. We promote particularly civil society groups to, for example, there's one civil society group which pushes this for the transport sector. There's another group which is not so much a civil society group, it's an industry organization which pushes this for the choice of motors, compressors, and so on. So what we are doing, and we would like to continue doing, is to build up these alliances so that ultimately consumers do get informed about the choices and the implications of their choices. They may still choose the inefficient option, that's fine. But at least they've made that decision after being fully informed of the implications of their choice.
Much of what you've talked about has been end use of energy, but India has one of the highest amounts of T&D losses, transmission and distribution losses in electricity. So does that also come under the purview of BE, and what steps are being taken towards that other than privatization?
Sure. You're absolutely correct that one of the single largest losses of energy that occurs in India is in the distribution system, not so much in the transmission system, but in the distribution system. And the reason I didn't talk about it was that it actually has an entire dedicated program which is focused only on that. The government has put up $10 billion for this purpose. And the way this works is that every utility has been given a goal, and the goal is you have to bring your distribution losses down to 15%. Here is the utility prepares a program and is given a part of this $10 billion as a loan. If they meet the 15% target, the loan is converted into a grant. So that itself is a very, very large program. It's happening in parallel. We track it, but we don't manage it.
Can you talk a little bit about the electricity rates in India? Is there some thought about having tiered rates and going on the lines of smart metering, advanced metering infrastructure?
Sure. Currently, rates to industry and commercial buildings are of the order of about 10 to 11 cents a kilowatt hour. For homes, they are tiered. The lifeline rates, which is anybody who uses less than 100 kilowatt hours a month, that is at something of the order of 4.5 cents a kilowatt hour. But if as a domestic consumer I use more than 500 kilowatt hours a month, then I jump to somewhere around 8 cents per kilowatt hour. So yes, and of course there is the agricultural sector, where for agricultural pumping the rate is almost zero. So obviously there are no incentives for them. That's a completely separate game, and I could spend half an hour just talking about what we are doing in that's a challenge. That for agricultural pump sets is a challenge. But what has happened over the years is that this rationalization of electricity prices has occurred. As I said, there is a lifeline price which is less than the marginal cost. The second issue is smart metering. Smart metering means many things, but at the very minimum it means that at various points in the distribution system, from the end user all the way to the supply, the generator, there is an infrastructure which allows for one, two-way communications, and number two, control over supply. So what is being done right now as part of the reform program, which I just talked about, the $10 billion program, is that money is also being given to establish this infrastructure, at least in urban areas. And the goal being that if the infrastructure is in place, then regulators can play around with different kinds of programs depending on what the consumer wants.
How has the reliability trends been shaping up in India in different regions, and have they hampered your efforts by creating an electric market that is uncertain, or have they helped your efforts by having more industries go to cogeneration, for instance?
It's worked both ways. The sheer shortage of electricity, this is not so much a reliability issue as a shortage issue, and therefore people's dependence on very expensive captive power, largely diesel, liquid fuel based power, has meant that energy efficiency has become that much more important. But the flip side of it is that the reliability issue, the fact that there is voltage excursions, has meant that the kinds of efficiencies that one can get, for example with refrigerators and air conditioners, we could not exploit all of it. So this is a tough question. How has it been shaping up? In general, it has been becoming better. In the first 160 towns where this program, the distribution reforms program, took up, there are 60 cities where reliability is now within acceptable limits. Incidentally, Delhi is not one of them.
More questions?
Hi, you spoke about the Bachat Lamp Yojana earlier, and I was just wondering if you could just tell us a bit more about how you account for perhaps failures of the CFL bulbs when you distribute them, because you're trying to do them at a very large scale, and the take back for the mercury in this. Do you have a program for that? And really concerned about that.
Sure.
Thanks.
The way it works is that the distribution area of a utility is broken up into a number of smaller project areas, each one of which has something of the order of 500,000 to 700,000 substitution possibilities in the domestic sector. The company which goes into each sector then goes home to home, selling these CFLs and collecting the incandescent bulbs. And the incandescent bulbs are actually kept in a particular place and counted by a third-party verifier that this has occurred. And every 6 months, there is a monitoring check. In a sample of the households which switched over, somebody goes in, this household had taken 4, do they still have 4, has it come down to 3, and so on. And therefore, the total savings are based on that. Mercury. With a program of this size, the amount of mercury that is being introduced is large, despite the fact that we have said that those lamps which come in have to be 3 milligrams or less, but nevertheless, just multiplied by 300 million, it's a very large number. So what we've done is first required the companies that are doing this to put aside a certain sum of money. We have recommended 5 rupees for each CFL as a mercury recovery charge. Right. How will this money be used? In each area where this is being done, or of several geographically connected areas, there is a recovery plant. And anybody who brings a fused CFL to the plant gets an incentive. So the first thing is that the collection of fused CFLs is incentivized. They get something like 2 rupees for it. I mean, this is not happening. This will happen in the future, obviously, as they, but it's been put into place. And the second, for each CFL that the recycler processes, he gets a certain fee, say about 3 rupees. So therefore, through this financial channel, we are ensuring that the fused CFLs are collected, because now they can be collected by the collection mechanisms that exist and end up in the recyclers' facilities.
Okay, thank you for stimulating questions, and I have one more pleasant duty to perform. I would like to present you with this commemorative plaque in recognition of your
thank you
work in promotion of energy efficiency and today's presentation.
Thank you very much, Robert. And I shall treasure this.
Thank you. Thank you for coming.